Hello and welcome back to another video. Here we are going to discuss the last three questions from October-November 2019 Probability and Statistics 1, that is 970951 now. So here is the question number 5. The time in hours that Devin plays on his games machine each day is normally distributed with mean 3.5, so it is mu, and standard deviation 0.9, so it is sigma. Find the probability that on a randomly chosen day Devin plays on his games machine for more than 4.2 hours. So we can see it is normally distributed. So we can take x, or I'll take t because it's a time. So time t is time taken by Devin to play on his game machine, and it is normally distributed, so the parameters would be mu, that is 3.5, and sigma square, because variance is sigma square, so it is 0.9 square. And according to the question, they are asking to find the probability that on any random chosen day the time by Devin is more than 4.2 hours. So we need to find the probability of t more than 4.2 hours, and which is in the standard normal distribution, it would be z greater than 4.2 minus mu, that is 3.5, over sigma 0.9, which will simplify and get z greater than 0.7777, and also I'll take 0.7778 till 4 decimal places. Now we can see the graph. 0.7778 is a positive quantity, so it would be lying somewhere here, and since z is greater than this, so we require this region, and this region is 1 minus phi of this z value, so it become 1 minus phi of 0.7778, and the value of this from the distribution table is going to be 0.7818, which is, when we'll subtract from 1, we'll get the answer. It is 0.2182 till 3 significant figure, it is 0.218. So I hope it is clear. Let's do the B part of this question. And here is the B part. On 90% of days, Devin plays on his game machine for more than t hours. For more than t hours, find the value of t. So if we understand it from the distribution graph, it would be very much clear. For 90% and more than t hours, it means it cannot be here somewhere towards the right part of this mean. It has to be here. That's why this is going to be 90%. And if it is 90%, then it means this z value for this corresponding to this t, we will get standard score, that is z, that would be negative. So we will calculate this corresponding to this negative z, positive z value, and that would also be 90%. And this area is going to be phi of z. But since it is in the negative side, we'll write the minus z here. Means the z value would be minus. So from here, this phi z is 90%, but the value of z is minus. So it is like same as phi of minus z in this case. So from here we can write this situation, and we know that t time was normally distributed with 3.5 and 0.9 square parameters. So the probability of t more than t, this is equal to given as 90%, 0.90, or we can write it as 0. This in the standard score, z is greater than t minus mu 3.5 upon sigma, that is 0.9, is equal to 0.90, or we can write after this t minus 3.5 upon 0.9 as negative of phi inverse of this value, because this t is towards the left hand side of the mean. So now phi inverse of this value is 1.282, so it become t minus 3.5 is equal to minus 1.282 into 0.9, and divide, then t would be the division of it, so minus 1.282 multiplied by 0.9 divide by, oh sorry, not divide by, it is going to be sum because it is here minus, so plus 3.5. so now we will calculate this. Minus 1.282 multiplied by 0.9 and plus 3.5, so the answer is going to be 2.3462, or we can say till 3 significant figure, it is 2.35 hours. So that's the value of t. I hope it was of some help. Let's do the next question. Now here is the C part. Calculate an estimate for the number of days in year 365 days on which Devin plays on his games machine for between this 2.8 and 4.2 hours. So we need to estimate the number of days. It means we are finding the expectation. So the expectation of this is going to be n into p, and here n is 365 into the p is the probability of time t to be in between 2.8 and 4.2. so all we need to find the probability of t in between this, that is going to be probability of, in the standard score, z greater than 2.8 minus mu, that is 3.5 upon sigma 0.9, less than 4.2 minus 3.5 upon 0.9. now we will calculate this, and we can see one value is going to be negative and the value is going to be positive, so we can write it as, we'll calculate this value. So the first value which we have already calculated, it was 0.777 and so on, so I write 778 z less than this 4.2 minus 3.5 and divide by 0.9, this value is going to be positive this, so 0.778. now this probability we will calculate by finding the probability means phi of positive value, this 0.778 minus the least value, so phi of minus 0.778. since it is minus, so it means towards the left hand side we need to find this value because it is minus 0.778, and in equivalent value we'll calculate here, that is 1 minus phi of this, so it becomes phi of 0.778 minus 1 minus phi of positive of this, and we'll solve, it is going to be 2 times phi of 0.778 minus 1, that is 2 times this value we have calculated in the previous question, 7818 minus 1. So 2 into 0.7818 minus 1, this is going to be 0.5636, so till 3 decimal places or 3 significant figure, it is 0.564, and hence the number of days will be 365 into 0.564, which is 205 and this value is 205.714, and it means that complete 205 days. So since it is a days, we will not take 206, it is 205 days. Now here's the question number 6. The times t minutes taken by 150 students to complete a particular challenge are summarized in the following cumulative frequency table. Time taken t, if it is less than or equal to 20, there are 12 students. Less than or equal to 30, there are 48. Less than or equal to 40, it is 106, and less than or equal to 60, it is 134, and less than or equal to 100 minutes, it is 150. And here is the cumulative frequency graph of these values, and we need to only take care of these points, and the curve should pass through all the points which is given, and it should be smooth and continuous curve. That's it. Let's do the B part of it. 24% of students take 5k minutes or longer to complete the challenge. Use a graph to estimate the value of k. So k would be somewhere here, and it is given that 24% of the students, so means 24% of the students is coming here in this. So of course this the minimum, this part from the 0 till this place, it would be 100 minus 24%, that is 76%. So we'll find this value, that this value on the y-axis would be 76% of the total data, that is 76% of 150. So 76% of 150 is 0.76 into 150. 150 into 0.76, this is 114. So the 114 value on the y, from the y-axis, will go to the graph and find the k value. So let's get back to the graph to find the value of k. So here's the graph, and 150, the 76% is 114, 110, so 112, 114. This is 114, that is 76% of the data, and which we will get back to graph here, and we'll come down to the value of, to get the value of x. Axis means number of students who take more than that. So this value is going to be somewhere here, and this is going to be 44. So k value is going to be 44. Okay, this means k is equal to 44. So above more than k minutes, 44 minutes, there are 24% of the students. So we are always going to convert, we'll always calculate like 0 to that point. So 24% are coming here, it means 76% will come here. To get this value, we'll do like that. Now let's do the C part. Calculate estimates of the mean and the standard deviation of the time taken to complete the challenge. So here I took the table. So cumulative frequency is given, we'll calculate the value of frequency, corresponding frequency. So it's like 0 to 20, 0 to 20 it is 12, and then 20 to 30 it is going to be 48 minus 12, so 36, and then 30 to 40, this range 106 minus 48, 6 minus 8, 8, and then 9 minus 4, 58 now. And from here, for this interval, it is 40 to 60, 134 minus 106, so 4 minus 6, 8, and then 2 minus 0, 2, 28, and the last one is going to be from 60 to 100. And this interval, the frequency, I'll write frequency here, the frequency would be 150 minus 134, that is going to be 16 only. So once we have the frequencies, we can estimate the mean. Mean is going to be sum of all the data, means we'll multiply by the mid value of each interval with the frequency. So the mid value here, it is 10, so 10 into 12, plus mid value of 2030 is 25 into 36, plus mid value of this is 35 into 58, plus Mid value of this is going to be 50 into 28 plus 60 and 100. The mid value is going to be 80 into 16 upon total frequency, that is of course going to be 100. The total data, that is 150. Now we will calculate this. 110 into 120, it is going to be 10 into 12 120. 25 into 36 is 900 plus 35 into 58, it is going to be 2030 plus 28 into 50, it is going to be 1400 plus 16 is 128, so 1280 divide by 150, so it is going to be 5730 divided by 150, which is 38.2, or in the fraction, doesn't matter. So this is going to be the minute 38.2 minutes is the mean time. And variance, in order to calculate the variance, first of all we will calculate the mean of the square of each data. Means we'll take 10 square into 12 plus 25 square into 36 plus 35 square into 58 plus 50 square into 28 plus 80 square into 16, and divide by total data, it is going to be 150, and minus the square of mean, that is 38.2 whole square. So we will calculate this now. Now it is going to be 1200 here plus 22500 plus 7, this will calculate from calculator of course, it is going to be 71050 plus 70,000 plus 102400 now, and divide the complete thing upon by 150 and minus the square of this. So this become, we'll add them, it is going to be 267,150 over 150 minus 38.2 whole square. So this is going to be divided by 150, 1781 minus 38.2 square, which is 1459.24, and this is 321.76. Now since we have the variance, so we can calculate the standard deviation, which is being asked from the question. Standard deviation is square root of the variance, that is square root of 321.76. so square root of this value is 17.937 and all, so it would be 17.9 minutes. That is going to be the standard deviation. So that was the question. Let's do the next question now. And here's the next question, that is the last question of this paper, 7th. Find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that all 3 E's are together. So if we take all 3 together, we'll take this as one alphabet, then we'll be left with 1 2 3 4 5 6 7 and 8 alphabets. So we are left with 3 E's together. I'm writing anywhere I can write, but I'll write in the beginning 3 E's together, then the rest of them as H O P K double E came here, P and R. So we are left with 1 2 3 4 5 6 7 8 alphabets, and the number of ways they can be arranged, it is going to be 8 factorial. And since there are two p's, so like p's, so it would be divided by 2 factorial. And since all e's are alike, similar, or you can say indistinguishable, so we don't have to arrange them, so it is only going to be always same. So this is the total number of different ways in which these 10 letters of the word of shopkeeper can be arranged so that all the three e's are together. And 8 factor, this value is 20160. 20,160 ways are there in which this thing can be arranged. Now let's do the B part. And here is the B part. Find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that p's are not next to each other. So first of all, we'll calculate total arrangement. And then we will subtract the arrangement with p's together. So if we'll subtract from total arrangement the arrangement with p's together, we will be left with those arrangements only where these p's are not going to be next to each other. And total arrangement, there are 10 letters, so it would be 10 factorial, divide by there are 2 p's, so 2 factorial, and there are 3 e's, so it is divided by 3 e's as well, minus the arrangement with p's together. If p's are together, then we'll take this 2 p's as 1, so we are left with 1 2 3 4 5 6 7 8 9, and then it become 9 factorial. And since there are 3 e's in that case, so it would be 9 factorial upon 3 factorial left. And this is the total arrangement, and we will calculate this now. So the first value is going to be 302400, and this value is 60 48 and then 0, and hence the final answer is going to be 241920. So this is the total arrangement where these p's will not be next to each other. I hope it is clear. Let's do the last. So C part is find the probability that a randomly chosen arrangement of 10 letters of the word shopkeeper has an E at the beginning and an E at the end. So we need to find the probability. So first of all, we'll find the number of favorable arrangement. In the favorable arrangement, we have one E in the beginning, one E at the end. So these two are fixed. Now once we have these two e's fixed, we are left with only 8 letters, and out of those 8 letters, 8 alphabets, we have 2 p's, like 2 p's. So it would be, we can arrange this in the factorial 8 factorial upon 2 factorial ways. And total arrangement would be, of course, 10 factorial upon 2 factorial 3 factorial. So the required probability is 8 factorial upon 2 factorial whole divided by 10 factorial upon 2 factorial 3 factorial. It is 20160 upon is 302400, and we'll cancel it. We'll calculate from the calculator, and this answer is going to be 1/15. So that's the answer. We can write in the decimal also, but this is fine. This is the probability where these two e's would be at end and at the beginning. Let's do the last question, last part of this. 4 letters are selected from 10 letters of the word shopkeeper. Find the number of different selections if the 4 letters include exactly one P. So it's a selection, so we will be writing all the possible selections here first of all. So first thing is P is required, I'm writing P, and there are three E's, so we need to take care of these three E's. So what is the first case if I'm saying that there is no E's at all? So all are different from E's. Second one is if I'm including one E, then two, only exactly one E here. Third one is if I'm taking two E's exactly, not more than that. And the last one is there are exactly three E's and one P. So we have done all the four selections, and after taking this P we are left with 8 alpha letters. And when we are fixing that there's no E, or we are talking about E's, so we have removed E's as well. We are left with only 1 2 3 4 and 5 letters. So in place in the number of different selection for these three places out of 5, it is 5C3, and then for these two it is of course 5C2, because we cannot choose E here, because one only exactly one E, and which we have fixed. And for one place it is again 5C1, and if there is nothing to put, so it is going to 5C0. So 5C3 is 10, 5C2 is also 10, 5C1 is 5, and 5C0 is 1. So total number of different selections is going to be 10 plus 10 plus 5 plus 1, and which is 26. So there are 26 different selections of 4 letters when we include exactly one P. So that's it. I hope it was of some help. So we'll meet again in the next video with some other past year paper solution. Till then, thank you so much.